Hi guys, my name is Jahanara Amir and I'll be going over Lab 3 magnetic field of a bar magnet. In this lab, we were to measure the distance dependence of the magnetic field due to a small bar magnet. We do so by comparing data and measurements to the distance dependence calculated by the on and off axis magnetic field equations. We also use GlowScript to create a function that calculates the magnetic field produced by a dipole using the Biot-Savart law. Some of the fundamental principles includes Biot-Savart law, which is basically the equation for magnetic field of a bar magnet. We also have distance dependence, which states that the magnitude of the magnetic field decreases as the observation location is moved farther from the bar magnet. Now on to experimental procedure and observations. We started off by finding the magnetic north using the magnetometer app on our phone, and we located the magnetometer chip in phone and marked it. We measured the distance at which the magnetometer record predetermined values for the magnetic field, and we recorded the values and repeated the same procedure for on and off axis measurements. Over the experiment, I observed that the magnetometer gets closer to, when the magnetometer gets closer to the magnet, the magnetic X component increases. On top of that, when the magnetometer gets farther from the magnet, the magnetic field is close to zero. These are my results and calculations. To the top left, you can see the on-axis field, and to the bottom, you can see the off-axis field. So the D perp is the on-axis distance from the bar magnet by Earth is the Y component from magnetometer app on-axis. D is the distance from bar magnet 45 degrees from axis. Bx, By, and Bz is the magnetic field values calculated 45 degrees from axis. And By corrected is the new bidirection, including Earth's magnetic field. Now on to the computational model. So I started off by creating a magnet at the origin and made a function for the magnetic field using a derivation of the Biot-Savart law. Then I drew 4 more arrows representing magnetic fields perpendicular to the axis. We found the D perp and the observation location 45 degrees from axis. And I drew another arrow representing the magnetic field 45 degrees from axis. So to the bottom right, you can see the model that I got where the orange arrows is the on-axis observations locations, the blue arrow is the perpendicular observation location, and the pink arrow is the 45 degrees off-axis observation location. Lastly, onto the questions we were asked, what if you hadn't oriented your experiment to compensate for magnetic north and had instead laid out your meter stick at some immediate angle with respect to Earth's magnetic field, how would your results have changed? I said that the magnetic field values would be less accurate because there would be a large difference between the experimental and the theoretical values. All the magnetometer readings would be skewed in the direction of the magnetic north. Lastly, what if you were to stick 2 identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? I said the direction would stay the same, the magnitude of the magnetic field would increase or even double. Thank you for watching, and I hope you have a good one. Bye.